picking up in Unit 1, Lesson 12, looking at Example 3. In this problem, we are going to use graphs to analyze the square root function. So we've got a real-world problem here. It's about a physics problem. And it says, when an object is spinning in a circular path of radius 2 meters with velocity v in meters per second, the centripetal acceleration a in meters per second squared is directed toward the center of the circle. The velocity v and acceleration a of the object are related by the function v equals the square root of 2a. So if this problem seems confusing to you, if you haven't taken physics yet, if you're not sure what's going on, this is just setting up all the math, setting up all the variables in the problem. But really all you need to worry about is this equation right here, v equals the square root of 2a. And so what we are asked to do is to graph the function in the domain. So just graphing the function, that doesn't require you to really understand any of the physics. It just requires that you understand what a square root function looks like. So we're going to make a table of values. They're going to start with the a value of 0. 2 times 0, obviously that's 0, and the square root of 0 is still 0. The next value I would probably pick if I was doing this table is, let me pull up the drawing tool. I would probably pick this value right here, a is 2, because I know that 2 times 2 is 4, and the square root of 4 is 2, so I get a whole number over here for the velocity. And then they use 3, 4, and 5. And you're always welcome to do that. You just need to have a calculator handy so you can figure out what the square root of those numbers will be. But if you want whole numbers, probably the next number I would pick, let's see, if I did 2 times, well obviously 3 gives me 6, that's not a perfect square. 2 times 4 is 8, that's not a perfect square. 2 times 5 is 10, that's not a perfect square. 2 times 6, that's 12, that's still not good. 7, that would be 2 times 7, 14. Let's go with 8. 2 times 8 is 16, the square root of 16 is 4. And then if I just use this point 0, 0, 2, 2, and 8, 4, basically if you have those 3 points, that's good enough to be able to draw the graph for your function. So here's our graph. Let me just pull up the toolbar, drawing toolbar again, so you can see where the points are going to be. We've got right here 0, 0. Then we have 2, 2, over 2, up 2. That's on the graph. And then let's see, 8, 4. Remember 8, 4 was the point that we added on here just so we could have whole numbers. 1, 2, 3, 4, 5, 6, 7, 8 over up 4 is right here. And you'll notice all 3 of those points lie on the line. So if you had just drawn those 3 points, then you could easily connect them with that curved line, the square root function, which remember that's just half. It's one side of a parabola that was turned on its side. So that's your graph. That's how you graph square root functions. Part B, now they're going to ask us to do something with our function, and they want to know what would be the centripetal acceleration, so what would be a, of an object spinning along the circular path with a velocity of 4 meters per second. So we know velocity is 4, and we want to find what a is. So we're just going to plug that in, or we could look at the graph. We could plug it in the function, or we could look at the graph. If the velocity is the velocity is 4. We're going to plug in 4. So 4 is the square root of 2 times a. And then what we're going to do with that is we're going to square both sides. And remember, the square cancels with the square root. So we're left with just 2a. And 4 squared is 16. Then you're going to divide by 2. And you get a is 8. So the acceleration, the centripetal acceleration, is 8 when the velocity is 4. And remember, that was a coordinate point that we had added onto the graph. All right, here's one for you guys to check your progress on. This time we have the equation v equals 0.094 square root of a cubed. This is going to be definitely a much more complicated graph. So I would suggest just picking a few values of a for acceleration, or no, not acceleration, it's surface area this time. Picking some values for the surface area, plugging them in, seeing what the volume would be, and then just plotting those points. You're probably not going to find very many points that are going to give you nice even square roots. So I would just pick maybe some points. Let's see, we've got 2, 4, 6, 8. We can go out to 8 spaces in the A direction. So I would try just a couple points, maybe like the origin, maybe like 2 or 3, some point a little bit farther away from 0, and then some point closer to the end, just so you can have a good idea of where this graph is going to be. So pause the video as long as you need to solve this, and then when you have your answer, come on back and advance to the next slide. Okay, our answer this time is B. This is the graph of 0.094 square root of a cubed. It's a little bit different looking from the other square root functions we've looked at so far. Okay, part B, now we're going to find the surface area. What would the surface area be if the volume was 3? So you're going to plug in 3 for the V, and then solve for A. Pause the video as long as you need. When you have your answer, come on back and advance to the next slide. And answer to part B is A. The surface area is 10.1 units squared. If they don't give specific units like inches or centimeters or feet or something like that, then you just want to use the word units. And area is always units squared, volume is always units cubed. Okay, for example 4, what we're going to be doing is graphing a square root inequality. Notice how we don't have the equal sign here, we have a greater than sign. So this is going to have to, you're going to have to draw back on some knowledge that hopefully you gained in Algebra 1 about graphing inequalities in terms of what kind of line you're going to make and where you're going to shade. But if you don't have that knowledge, I will obviously be talking about it in the video. Wow, so they just threw the answer out at you. What I would suggest doing is, again, making a table of values, thinking about some values that would fit on this graph. But the first thing that you want to find always is what your x-intercept is going to be. So you want to figure out, when is y going to be 0? So if I pull up my drawing toolbar, if I set y to be 0, and when you're doing just solving specific points, you can use the equal sign instead of the greater than sign. But then so I want to find when 0 is going to equal 3x plus 5. So I'm going to square both sides. Obviously 0 squared is just 0. And the square and the square root cancel out, so you have 0 equals 3x plus 5. And then that's just an Algebra 1 equation. We're going to subtract 5 from each side, and then we're going to divide both sides by 3. And so we'll end up with negative 5/3 is x. So that's this coordinate point right here. This is about negative 5/3, which is negative 1.6, and 0. Notice how it's an open dot. The open dot right here happens because there's no equal to. It's not greater than or equal to. It's not that. It's just greater than. When it's greater than, your dots are open dots. If they have the equal to, then you want to fill in your dot. The other thing is when you have a greater than sign, if you're missing the equal to part, this would give you a dotted line. And if you did have the equal sign, you would just be drawing straight lines that aren't dashed and broken like this. But since we have just the greater than, that's why we have a dashed line here. And And then, so once we start off with this, we'd find some other points that fit on that graph, and you can probably just do that using your calculator. You don't have to find exact values. If you did want to find an exact value, it would be a little bit more algebra. You might want to find like this, find out when this, like if this was the square root of 9, you could figure out, because you know the square root of 9 is just 3. When does 3x plus 5 equal 9? And then that would be some algebra that you could solve. But it's going to be easier, again, if you just type this equation into your calculator and go and look at the table on the calculator, and then you can graph the points that way, just by graphing a couple of the points and then connecting the dots. So here we go. Since the boundary should not be included, it's not included because there's no equal sign on here. The graph should be dashed or dotted. The domain, again, is anything greater than or equal to -5/3. That was where we found when y is greater than the shaded region, it should be above the boundary. And then you can take a point and you figure out if it's in the region. So hopefully one thing you remembered from Algebra 1 about inequalities is that not only do you have to think about whether the line is dotted or solid, you're also going to be shading either above or below the line. And the sign right here tells us where we're going to be shading. But let's go back to this next slide and see what they're talking about here. So we need to pick a point to see if it goes in the shaded region. So the easiest point I'll always, to check is the origin. So if we plug that in, 3 times 0 plus 5, and the square root of that, is 0 greater than that answer? Well, 3 times 0 is 0, 0 plus 5 is 5. The square root of 5 is some positive number, and 0 is definitely not greater than a positive number. So this point 0, 0 is not going to be shaded. So if we go back and look at this graph, 0, 0 is right here, so everything below this graph is not going to be in the shaded region. So let's advance ahead and see what they're talking about for the shaded region. And so you can see here that they shade everything above the square root function, and notice that they're not doing anything to the left of the function. They're just starting right from this point, -5/3, and straight up, and then everything to the right of that is also above the line. Never go to the left of your square root. All right, here's one for you guys to check your progress for. Figure out which one is the graph of y greater than the square root of 2x plus 4. Pause the video as long as you need. Get your answer. When you have your answer, come on back and advance to the next slide. Okay, our answer this time is letter D. Notice again, when they shade, they're shading above and it's dotted because of the greater than sign. If it was greater than or equal to, it would be a solid line. If it was less than, it would be shading below. Greater than, you always shade above. And notice how when we're shading is directly above this x-intercept, straight up, and nothing to the left, nothing below it. Okay, that's the end of Unit 1, Lesson 12. Go ahead and work on the classwork